Good morning, friends. I hope you are seeing a beautiful another variety of saurus, and this is called as another animal, I would say. And I was surprised when I saw this kind of image, and it was called normal curvy saurus. And the moment I saw it, I could understand what it was. It was like a combination of normal curve plus dinosaurus together. So normal curvisaurus. So I welcome you all to another playlist of mine wherein I'm going to focus exclusively on the probability distributions, and this particular image that you are able to see is the way in which I'm going to welcome each one of you. Now, I have one more image with me which I was going through Quora, and I was able to check out with this one. And please, this is a very good statistic joke, and if you can look at it, you will understand it. A man, a serious man with a newspaper and goggles, looking at the so-called waiters. And now the question is why cetaceans don't make it as waiters, and see the sentence or the statement given by the man in blue t-shirt, I would say, round necked one, and he's showcasing the something, and you can see again the bell curve over there. He says, "Hi sir, I normally distributed the butter on your toast this morning." So I was just wondering, okay, the waiter knows statistics, number one, especially with the probability distributions, and that's why he is either working out on some kind of a probability or this one. So jokes apart, this is how another way that one can look into it and find it out. Now, usually whenever I am introducing to my playlist, I start off telling them what I will be doing. However, here I am stating what I will not be doing. So here you can see giving general definitions, doing basics of distributions pertaining to one software exclusively, so forth and so forth. And you will see as I keep on progressing further, you will be able to see what all things I would be taking care of. So what are we going to learn then? So the jargon which is there for the probability distributions, trust me, when I was looking at it, I myself learned a lot. I thought, okay, let me go ahead and share it with everybody so that they are also aware of it, and if possible you can definitely use it in your own research work also. Different probability distributions and their distribution functions plus their properties. So there are different varieties of probability distributions we will see, and once I saw the list I said, oh my god. And then there were these distribution functions also and their properties, and that's where my interest was awakened, and I thought, okay, I need to learn these things also. Create and plot the distributions. Two of the programming languages that I like a lot is Python and R. Now both of them are very easy. I mean, I started off my learning experience with R, so the moment I completed little bit I should say of R, I was very comfortable with Python. So I think all of you also will be in the same manner. Now here, before I can start off anything, there is a need to understand what is random variable. Now you see, most of the time whenever after doing few courses on Python or R, I was saying that let's generate random numbers, let's generate random variables. So I was just wondering, there is a need for us to understand even these terminologies also. So what is a random variable? It is a variable whose possible values are numerical outcomes. So we are just focusing on numerical outcomes, no characters out here, outcomes or strings in that case of a random phenomenon. So if there is a phenomenon taking place, or a situation or an event which is taking place in the environment, given environment, then we are going to pick up and understand what are the numerical outcomes of that particular random phenomenon which is there. And one has to understand even this thing that random variables are going to be distinguished into two forms. One is the continuous one, the other one is the discrete. So continuous and discrete are the two random variables that one has to know. So what are the differences between them? So that is, if you're curious, that is how it would be coming in. What is this continuous and discrete? So here comes in the differences between them. I would be starting off first with discrete, and then I will come to continuous. Now discrete, you can see it takes on only countable numbers. So where can you find discrete? Only when you are able to count the numbers of distinct values or is simply countable. Now since it's a countable number, we can say it is quantified in that way. Now examples will be rolling of a dice. Now I don't know how many of you are fond of playing Ludo or snakes and ladder. I mean the childhood games. However, sometimes if I'm feeling very bored up, I definitely go ahead and start playing Ludo or even the snakes and ladder. So here you can see all of you must have seen and had experience for those dices also, maybe single one or two, that's up to you. Number of chickens in a coop house, that's another example that literally you can count and how many chickens are there in that particular place. The number of passing scores in an examination, so we even know how many students have passed and how many of them have failed once there is an examination which is going to be conducted, and we know how many of them are quantified under the label of pass and how many of them are excellent, so on and so forth. You can carry forward as per your convenience. The number of voters in the pool booth. Now this is also something we know as to how many voters are there, how many players are there in a game. All these things are quantified and we are aware of it. Under discrete distributions, the different forms of them are Bernoulli distribution, binomial distribution, Poisson distribution. Now when initially when I was learning research methodology, okay, when everybody used to take these names, I used to look at them. How can they just talk about Bernoulli, binomial, Poisson without even defining to you what these are? Okay, so these are some of the examples, and that's what my curiosity raised, and I thought, okay, I have to learn these things also. Number one. Number two, even in Neeraj sir's, if most of you have attended his workshops or the faculty development programs, you will see that he will literally allow you to take out your notebooks, give you the random sequence of numbers, and he will say, now plot the different graphs, and then he will go to person and he will see how you have plotted the graph, and he will suddenly laugh and he will say, do you think that the graphs is going to be linear, or this is how the things are going to be for you? Now that's what I was just thinking, that yes, he is having nice fun, definitely yes. However, where do I lack? No, so one has to be very honest and truthful to say that yes, we do not know. So here we go. So this is how I started off, and I said, okay, now I have to learn these things also side by side. Now coming to the continuous one, you can see that it takes an infinite number of possible values. So here when it is infinite, you cannot count. But however, you know that yes, there are some numbers which are present. Now, defined over an interval of values, it is represented by the area under a curve or the integral. Now, you see, one has to understand and find it out, within that curve, how many points are there, how many dots are there. It's infinite, you cannot. Now, examples for continuous distribution would be for pressure, height, mass, weight, density, volume, temperature, distances. Okay, so these are some of the, and examples for continuous distributions would be beta distribution, normal distribution, exponential distribution, etc, etc, etc. So here you can see beta 1, 2, 3, 4, 5, 6, 7 distributions already I have introduced to you. So do we have more of them? So keep watching in my next presentation, where I would be discussing about the different kind of distributions that are available under probability distributions. Till then, thanks for watching. Take care. Bye.